Alright. Sorry about the delay. I had to make sure that we were actually recording. Had a little trouble the other night, so keep double checking, make sure we're actually recording. So this should be the video you're watching Tuesday night in preparation for Wednesday's class. We're going to do a little lesson recap tonight. We're going to talk about similar figures. Okay? Similar figures are polygons, or really any shape that have the same shape, but they have different sizes. We also call this similarity, proportionality. The factor by which we find something to be proportional is often referred to as the scale factor. So this little intro that I've written out here, I've highlighted the important words: similar figures, proportionality, and scale factor. Now, to work with these three words, we're going to do example 1 and example 2. Now, example 1, we're going to put you in a situation. We're going to say you are at the county fair, and the county fair charges you $72 for a 12-foot by 10-foot booth. Now, you were talking to a friend, and you found out that the cost is proportional to the square footage. Well, what that means is, first, we're going to have to find the area of this 10 by 12 as well as this 12 by 14, so that you can find out what it would cost to upgrade to a 12 by 14 booth. So first we're going to find the area, okay, our square area, which means we have to use 10 times 12. Simple math, 10 times 12 is going to give us 120. Well, our square footage is going to wind up being the top of our proportionality fraction, and our cost, $72, is going to be the bottom. Now, in order for us to make this a proportional problem, we're going to have to set this one up the same way, which means since we don't know cost, it's going to go on bottom, and since we can find the square footage on the top, we're going to go ahead and work that out. Now, 12 times 14 is a little bit tougher to do in your head, but if you start with 12 times 12 and know that that's 144, you can add 24 to that. So 12 times 14 would actually give you 168 square feet. So here's our 168 square feet. Now if we cross multiply and divide, we'll find our answer. Okay? Now our cross multiplication, I'm going to go ahead and I'm going to use a calculator. We're going to make this quick. 72 times 168. Well, 72 times, clear this out, here we go. We'll put this on here for you. So, 72 times 168 gives me 12,096. So I'm going to write that down. Here's my 12,096. That would go inside the house of my long division. What would go outside is what I've boxed, the 120. This whole thing's going to be divided by 120. Well, we can see this part real quick, that 120, that's going to be 1 right there. But we'll go ahead and use the calculator to go through it. So, 120, 12,096 divided by 120, $100.80. Okay, so let me move this over. $100.80. So I'm going to write my answer over here. I've got a lot of mess right here. It's hard for me to read. If I was a teacher, if I was turning this into my teacher, he'd be going, man, you can't see anything. So what I'm going to do is I'm going to write over here. I'm going to say, under my example, cost that we didn't know is actually equal to $100.80. Fair enough? All right. Not too complicated. Fairly simple. So, similar shapes, for example, number 2. We got two similar shapes, 10 to 12 on this first shape, and 2.5 to, well, we don't really know. Now, we've talked about similar shapes, and we've talked about similar pictures. When you actually have a drawn picture that's similar, take your pen and draw a line between the two numbers you have. Now, on the second picture, you may draw a line as well, but the line needs to go the same direction. So notice my line goes from up to or high to low here, high to low here, as it goes from left to right, left to right. So what that tells me is 12 over 10 and question over 2.5. So if I write that out, 12 over 10 is equal to what we're looking for over 2 1/2. I actually just cross multiply and divide that. Now if I want to make my life a little bit easier, I can reduce this fraction right here. And if I reduce this fraction by 2, I wind up actually with 6 over 5. And 6 times 2.5 is a little bit easier than 12 times 2.5. 6 times 2 is going to give us 12. And 6 times half is going to give us 3. So 12 plus 3 is going to give us that 15. Okay? So we'd have 15 in the house, and we'd be dividing by 5. Well, 5 goes into 15 3 times. 3 times 5, there's my 15 to check it. Zeroed out. Question mark that I'm looking for is 3. Again, I'm going to come over here and put, hey, the question that we were looking to answer is 3. Go ahead and box it up. Easy to find answers. So hopefully this jogged your memory a little bit on proportionality, on similar figures. Okay? And remember, this directly translates into dilations. Okay? Same way we use proportionality here, we use it with dilations. So I'm going to flip this over, give you 2 examples to get done before you come to class, and we'll call it good. So example number 1. Example number 1. Practice problem number 1. You can draw this little right angle triangle for me. And we're going to give it a size length of 4. And this side length of 2. And we're going to make this sucker bigger over here. So we're actually going to be increasing our scale factor that we'd use would be to get bigger. We're not going to know this side. We're going to say this side is 11. Set up the proportionality, cross multiply and divide. Okay? Number 2. Oh, let's bring back my favorite little friend here, as we have a light pole that is casting a shadow. And we're going to say our light pole is 10 foot tall, and it's casting a 4-foot shadow. And my favorite little buddy right here, we'll call him Bojo. And Bojo is going to be 4 foot tall, and he's going to cast a shadow that, well, we just don't know how long his shadow is, and we have to figure it out. Same thing, you've got 2 pictures, set it up, cross multiply and divide. I'll see you guys Wednesday afternoon. Enjoy it, have fun, don't eat too many cheeseburgers.